This presentation is about algebraic fractions, which are just fractions that have algebra in them instead of regular numbers, or as well as regular numbers. And all of the rules that apply to fractions apply to algebraic fractions. So for example, if you want to add two fractions, the bottom numbers, the denominators have got to be the same. And generally speaking, you get rid of the fraction by multiplying by the bottom. So we'll see some of that in action in a minute. Here's an exam question. Prove that x plus 2 over x minus 1 over x plus 1 equals 2 brackets 2x plus 1 over x brackets x plus 1. Well, I'll start with the first bit of that, and I'm going to multiply the top and bottom of the second part by x. So everything there has been multiplied top and bottom by x. That's just like multiplying by 1, multiplying by x on the top and x on the bottom. So it doesn't make it any bigger or smaller, it just puts it in a slightly different form. And I'm then going to take the first one and multiply everything by x plus 1 on the top and x plus 1 on the bottom. So again, all I'm really doing is multiplying it by 1. So it doesn't get any bigger or smaller, it's just in a different form. So I've multiplied each fraction by the bottom part of the other fraction, top and bottom. So everything in the first fraction has got multiplied by x plus 1, top and bottom, and everything in the second fraction has been multiplied by x, top and bottom. And having done that, they've both got the same thing on the denominator. They've both got x times x plus 1 at the bottom. And because they've both got the same denominator, we can then combine them into a single fraction. And then we can tidy this up a bit by multiplying those brackets out. So x times x gives me x squared, 2 times x plus x times 1 gives me 3x, and 2 times 1 gives me 2. And then x times x gives me x squared, and x times minus 1 gives me minus x, and then it's a minus outside all of that. So if I want to write that without the brackets, I have to remember that I've got a minus outside the brackets there and a minus inside, and minus minus is going to make plus. So when I write that without the brackets, that becomes a plus x because it's minus minus. I can tidy all this up a little bit because I've got an x squared and a minus x squared. They cancel each other out, and then a 3x plus an extra x goes together to make 4x. So I can write all of that as 4x plus 2 over x times x plus 1. 4x plus 2 on the top can be factorized because both of those things divide by 2. So I can write that top bit as 2 times 2x plus 1. And now that I've got it in that form, I've completed the question, because the question was to show that that whole thing came to 2 times 2x plus 1 over x times x plus 1. So I've shown that it's that as given and completed the question. Here's another question. Solve the equation 2 over y plus 1 plus 3 over 2y minus 3 equals 1. So this time we've got to solve the equation, which means that we've got to find out what y is that makes that balance. So we need to just try and get it in the simplest form possible by multiplying things out both sides or adding things both sides. So we really want to try and get rid of the fractions. So starting with what we've got, I don't like the fact that 2 over y plus 1 is there, so I'm going to multiply everything by y plus 1. to make the bottom of that fraction disappear. So 2 over y plus 1, multiply it by y plus 1, and then the bottom disappears. But then I've got to multiply everything else by y plus 1. So I'm doing that there and there. And then if I do that, I can then multiply everything by the next denominator. So to get rid of the 2y minus 3 on the bottom, multiply by everything by 2y minus 3, and then it disappears from that middle one, because divide by 2y minus 3 and multiply by 2y minus 3 cancel each other out. But then I've got to multiply everything else by 2y minus 3. Well, that looks complicated, but at least we've got an equation that doesn't have any fractions in it anymore. So we can actually tidy that up a bit by multiplying these brackets out. And that's what you get. You can check that yourself. And then bring the terms together. So for example, 4y plus 3y makes 7y. Minus 6 plus 3 together make minus 3. And 2y minus 3y will make minus single y. So I'll move that up there and do all that. 7y minus 3 equals 2y squared minus y minus 3. And if I add 3 to both sides, then the 3's disappear both sides. And then if I take away 7y from both sides, I get 2y squared minus 8y equal to 0. Well, I can divide everything there by 2 to make it a bit simpler. 0 equals y squared minus 4y. Just move that up the top. And that factorizes, because both of those things divide by y. So I can write that as 0 equals y times y minus 4. Well, if two things multiply together to give you 0, the whole thing will be 0 if either of the things we're multiplying will be 0. Because 0 times anything gives you 0. So that will be 0 if y is 0, the first thing we're multiplying, or if y minus 4 is 0, the second thing we're multiplying. Well, if y minus 4 is 0, y's got to be 4, so our solutions are y equals 0, y equals 4. So there's two possible solutions, y equals 0, y equals 4. Okay, so we're just going to check that out by putting the numbers in. So there's the question again. If I put y equals 0 into that, I get it all working out to 2 add minus 1 equals 1. And that works. Then if I try the same thing with y equals 4, it all works out to 2/5 plus 3/5 equals 1. And that works. So y equals 0 and y equals 4 are both solutions that make that equation balance. And that was algebraic fractions.